Okay, so I want to continue with the chapter 2 that we were doing before. So reviewing for the final, still with the chapter 2 material. All right, so we were looking at, I wanted to look at the fraction one. Okay, this is number 15. All right, on this one, we have these denominators and fractions. And so we can look at the denominators and we can pick a number that would allow us to clear out the fraction. So we're going to use 14 in this case. So I'm going to multiply by 14 everywhere. Okay, when I do, the 2 would go into 14 7 times, and then that first term would become just 21x. Then I still have minus 14x. And don't forget, you multiply the x by 14, even though it doesn't have a fraction. Here, the 14 would go away. Here, 7 would go into 14 twice, so we'd have minus 12. Okay. All right, then at this point, these two are like terms, so that would become 7x equals x minus 12. Okay. And now we're ready to get the x's together, so I'm going to take away x from both sides. That becomes 6x equals negative 12. Don't lose that negative right there. And then you're going to wind up dividing by 6 on both sides and getting x equals negative 2. So that strategy was clearing the fractions. Okay. Now, if you don't want to clear the fractions on a problem like that, then you need to understand how to handle it using your fraction keys. Okay, so if you're going to use your fraction keys, these are like terms. This is an understood minus 1. So you could do 3/2 minus 1 on your calculator, and that would give you 1/2, and you'd have 1/2 x. Okay, then you'd still have all this. This x over 14 is really 1/14 x. It's on the other side of the equal sign. So you could subtract it from both sides like this. Okay. To knock it out. And you'd wind up then having just negative 6/7 over here. And over here, you would do that on your calculator. Okay. And when you do, you'd get 6 over 14. Actually, it would simplify it for you. If you did this on your calculator, it would wind up being 3, what would it be? So it'd be 7/14 minus 1/14. So it'd be 6/14 divided by 2. That would be 3/7. So it'd be 3/7 x. Okay. All right, and that's what it would give you on the calculator. So what you would do is the 1/2 minus 1/14, which is the 3/7, and then just put the x back on. Then you could just divide by 3/7. So this is the approach if you're not going to clear fractions and you're going to use your fraction keys. So 3/7 divided by 3/7 would leave you just x. And then when you do that on your calculator, it would wind up giving you negative 2. Just type it in as negative 6/7 divided by 3/7 using fraction keys. Okay. And it would give you negative 2. So you can just keep the fractions and use your calculator. All right, so the next thing we got into, the next thing in chapter 2 we could do is either formulas or inequalities, right? Once you know how to solve an equation, you can go and work on formulas or you can work on inequalities. So I don't think you'll have a problem with number 17, but let me help you with a problem like number 18. I equals P RT. Okay, and let's do 19 also, where you had A equals P times 1 plus NR, and you're solving for N. Okay, so here you're solving for N, here you were solving for T. Okay, all right, and what I do recommended you do on ones like this is that you put the side that you got the variable you're solving for, put it on the left. I think that helps conceptually. Okay. Okay. Keep in mind what it is you're solving for. All right, so let's go ahead and finish 18. So we're looking at how P and R are both multiplied by T. So I'm going to divide by PR on both sides. Okay. When I do, the P's and the R's are going to cancel, and I'll have T equals I over PR. Remember to watch the capitalization. It needs to be capital I, capital P, but lowercase r. All right, now over here, there's different approaches you could do, but probably the best thing or the first thing that would come to mind is to distribute the P. Okay, and then keep track of what it is you're getting by itself. It's the N you're trying to solve for. So this problem can make you wonder what you're supposed to do sometimes. So it's basically this question. And so whatever you would do first over here is what you would do first with the variable. So like subtract 5 is what you would do first there. So that corresponds to subtracting the P. So that's what we'll do. So then we wind up with just P and R equaling A minus P. And don't forget what you're solving for. Keep that circled as you go down. Now we're pretty much back to where we were on the other problem, trying to get M by itself. You got multiplication around that. So divide by the P and the R. Okay, and so your final answer would be that N would equal A minus P over PR. Now watch the capitalization in lowercase, and then they probably will have N equals sitting there, and you'll just type in that side. Okay. All right, so that's pretty much all there is with the formulas. Okay. Now with inequalities, that's the other thing we could do, linear inequalities. All right, what I want you to think about, the second you see an inequality symbol, if you're trying to solve something like number 20, negative 6x plus 36 is greater than or equal to negative 6. The first little mental reminder I want you to make is flip the inequality if dividing by a negative. Okay? That's the first thing you should think, negative number. All right, so you just approach it like you did when you were dealing with equations. These are on opposite sides, so we have to add the opposite. So we have negative 6x is greater than or equal to negative 42. Now right here, since that's multiplication, I'm going to divide, and that's the moment at which that sign needs to change. This would become positive 7. This would become x less than or equal to positive 7. All right, now what you're asked to do with inequalities is to go on and do interval notation. And my math lab will ask you to do the graph, interval notation first. You really should do the graph first. So you see how this is telling you the solutions are all the numbers that are less than or equal to 7. Remember also that if you have the or equal to, that's a bracket. So we're going to put a bracket on the 7. If it had been just strictly less than, we would have used a parenthesis. If you'll do that first, then you just take the left side and the right side of the shaded region, and that forms your interval. And then just bring down the bracket. Also on inequalities, it was always going to be a parenthesis. So this goes towards negative infinity. This goes to positive infinity. Okay. All right, so I think you can handle 21. It just has variables on both sides. 22, people miss this. It's actually a very straightforward problem. So I wanted to show you the concept here to see if you could not miss it when you do it. All right, so this is called a 3-part inequality. It's got these 3 spots right here, 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 and here. The variable is only going to be in that middle portion. Okay. It's really a compound inequality, but you don't want to treat it separately. You don't want to write it separately. You want to just say to yourself, I'm trying to get that x by itself. This is times, this is plus, so I know I'm just going to subtract 4. And then just do that to all 3 parts. Don't just do it to the middle and the right. That's the mistake. People do it here, and they don't subtract 4 from the left. So that would become negative 6. In the middle, we have 2x. On the right, we have 2. Right, and see how that winds up then just having a problem where we got to get rid of the 2 that's attached to the x by multiplication. So we'll divide, whatever we do to one part, we do to all 3. That becomes negative 3 less than less than x less than or equal to 1. Okay, and then your graph for this, really, you should just think about what it's saying. It's saying x is between -3 and 1. That would be a parenthesis because it doesn't have the or equal to. This would be a bracket because it does. And then bring down the left and the right side and just put those symbols around it. Okay. All right, and then one more kind of inequality you sometimes get is one like 23, where they have the words and or, and we use that like an ad for a job to help us remember what you do. So if you have an or, you could have the degree or experience. So you could have one thing, the other, or both. Or degree or experience. Okay. Okay, less than 2. All right, they're both greater than and less than. Okay, so sometimes you'll have inequalities that are a little messier to work. On this one, we're just here getting each inequality solved for the variable. So x bigger than 6. Over here, I would take away 3. Okay, I'm not flipping the sign on either of these because I wasn't dividing by a negative. So that would be x is less than -1. Still not thinking about the word or. I'm going to do my scratch work picture. I like to just show these key numbers and think about it. So this one I'll do in blue. Here would be all the solutions bigger than 6. Okay, this one I'll do in red. Here would be all the things that would satisfy that. And with the word or, it can be one thing or the other or both. You do not need an overlap. So that means your final answer would be all of these together with all of those. Both of these didn't have the or equal to, so you would just use a parenthesis on those. Okay, so this is the one where you bring down the left side and the right side, and you have this gap, so you're going to use a union symbol, and then come over here, pick up at 6, and keep going to positive infinity. And that would be your final answer on that one. Okay, do the graphs first would be my recommendation on that. All right, I'm going to stop the video for this portion here, and then we'll continue with chapter 3.